How are you, my friends? I'm continuing with my algebra course, and this video is about lecture 3 that will cover sets, intersections, and unions. Please, to check the lectures of this course, algebra course, you can go and visit the playlist Algebra Course Lectures. This is lecture 3, as I mentioned. Let's start with some definitions. What is a set? Many people, they know what is a set, but maybe they cannot say the definition. A set is a collection of objects or a collection of elements. Sets are commonly written as using set braces like this. So we can have set A, set B, set C, set D, set E. We can have letters, we can have numbers, like we have set A here, 1, 2, 3, 4, as you can see. We have set B, A, B, C. We can have letters, we can have names, we can have countries, we can have anything, elements inside the set. Now we have two types of the set, finite set and infinite set. Finite set, as the word, it means limited number of elements. So we can count the elements, how many numbers, how many elements, how many objects are there. Like you see set X here, -2, -1, 0, 1, 2. That's it. Limited number, 5 elements inside the set. So this is finite set. Also set Y is finite. It's the numbers 5, 6, 7 until we reach 13. So we can count them. Infinite set, it has unlimited number of elements. Let's take this simple example. Set E, the last line here. You can see set E. What is set E? It's the number of fractions between 0 and 1. If you ask yourself, how many fractions between 0 and 1? You can just try to think of 1/2, 1/3, 1/4, 2/5, 3/7, 1/9. So this is unlimited number of fractions between 0 and 1. So this is infinite set. Now set builder notation. This is a way, a method, notation, how to build a set. You build a set like you build your house. So you can find the elements or the numbers of the members of this set. So we have X such that X has a certain property. Let's look at set G. Set G is X such that X is a natural number between 2 and 7. So we can look and find, search for the numbers, natural. Remember, natural numbers, you can find the definition of natural numbers in lecture number 1. So natural number between 2 and 7. 2 and 7 are not included. So what are these numbers? So these numbers are natural numbers. So this is set G. Now we can write, see the last line here, set G would be 3, 4, 5, and 6. So there are 4 elements in this set. Now, 3 definitions, I think, here in this slide. Null set, subset, belongs to. It's very important in algebra that you know the meaning of these terms. Null set is the empty set, simple. It's a set with no elements. Like we have a classroom inside with no students. So this is a null set or empty set. We can write it as empty or we can write phi. Now if you write phi inside braces like this here, this is not empty. The empty is nothing inside. Now subset, when you have A is a subset of B, that means every element in A is also an element of B. So A is a subset of B. Like this diagram here, you can see on the right side. So there is A, all included in B. So every element in A is also an element in B. So we use subset if we compare two sets. Listen carefully, please. We use subset if we compare two sets. We use belongs to, third one here, if we compare an element with a set. That's the difference. So X is an element, belongs to B. You see in the diagram here, X belongs to B. X does not belong to A. So we say here belongs, and then we write dash, that means does not belong to A. Again, I will say, if we compare two sets, we use subset or not subset. If we compare element with a set, we use belongs to or does not belong to. I think easy, nice example here. We have 5 sets, set U, set A, set B, set C, and set D. I advise you here, take a little pause, please. And I put 7 simple questions. 1, 2, 3, 4, 5, 6, 7. Yes. True, false. Just read, compare, look at the given, and tell yourself, write on a piece of paper, true or false, and then we can check on the next slide the answers together. So let me start. We have set U, 1, 3, 5, 7, 8, 13. We have set A, we have set B, we have set D, 1 and 8 only. Let's see. I'll take the first one, please. D, subset of B. So I have to compare and go there. D, 1, 8. 1, 8. Is this a subset of B? B, 1, 3, 7, 8. Yes. All the elements of D are also elements of B. So we can say in mathematics, D is a subset. We cannot use here belongs to. So we have to use subset. So that's true. Now, same way, you can try the other 6. Take a minute and then we can continue together on the next slide. I think you have enough time to try them. Let's see. B, second one now. I answered the first one. Second one, B, subset of D. See second one here. B is a subset of D. B, 1, 3, 7, 8. It's not. So the answer is false. Now, this is a little tricky. C is not subset of A. C is not subset of A. Look at C. 3, 8, 13. A, 1, 3, 5, 8, 13. C is a subset of A. When I write in the question here, C is not subset of A, that's false. Phi, subset of B. True? Phi is an empty set. An empty set is subset of B. It is true. I wrote here a note at the last line you can read. If E is any set, phi is subset of any set. Because phi is empty set. It is always inside any set. Okay, let's see. U equals A. U 1, 3, 5, 7, 8, 13. Is it? No, that's not. 5 belongs. You see now? 5 belongs to B. So where is B? B. 1, 3, 7, 8. 5 is not there. 5 belongs to B. False. 0 does not belong to A. See, A, 1, 3, 5, 8, 13. 0 is not there. Yes, it is not there. But use the symbol does not belong. Intersection. I think this is so easy. Everyone know what is intersection. Intersection is the set of all elements belonging to both sets A and B. Simple, easy example, like if we have a math class and a physics class, and we have 3 or 4, maybe 5 students in both classes. So these 5 students are taking math and they're also taking physics. So these are in the intersection. As you can see in the diagram here, this is set A, this is set B. A intersection B will be this area here. All the elements in the common. So we use the word and. And means in A and in B at the same time. Simple example here, the last line I wrote 1, 3, 4, 7. This is set A. 3, 4, 5, 6. What is the intersection? Let's see. 3 in both, 4. Yeah, so A intersection B is 3 and 4. You can write here, see. A simple example here. We will see other examples. Now, before the other examples, we have to understand the word disjoint. Definition, what is a disjoint? Disjoint means not joint, no connection. Two sets are called disjoint in algebra if there are no members in common, no numbers in the intersection. That means the intersection is phi, or the intersection is empty. Remember the intersection only. If the intersection is empty, then we call the sets are disjoint sets. So example here, we have set A 50, 51, 54. Set B 52, 53, 55, 56. If somebody say find A intersection B, just look at A and B. No intersection, we write phi. That means if we say, what do we call these sets? Disjoint. All right. Try at home. As I mentioned before, you will see many questions. Try at home in lecture 1, 2, 3 until we finish the whole course. You can try them. In the next slide, you find only the answer. If you need the details, you can check other videos. Now, union. Union. This is the symbol for a union. Union is the set of all elements belonging to A or B. So we take all the elements in A or in B. We cannot say the word and here. If we say A and B, that means the intersection. So we use the word or. Remember, be careful. I will go back and show you the definition of the intersection. You see here, and A intersection B, all the elements in A and in B. You have to use and. In the union, we use the word or. So it is in A or B. That means all the elements in A, in the intersection, in B. So this is a union. Like, look at this example. A 1, 3, 5, 7. B 3, 4, 6. Find A union B. Find all the points in A, all the elements in A, all the elements in B, all the elements in the intersection also. So it will be 1, 3, 4, 5, 6, and 7. That's the union. All right. Try at home also. I put here 3 examples. You can try them. The answer in the next slide. Not difficult at all. Now let's see example 10. Oh, nice. This one you can try now because I will explain the answer after a few seconds. So this is M0246. This is N13579. This is Q024681. Find Q intersection in the bracket M union N. Very nice question. You can try now. You can pause a little, please, and try on a piece of paper. Then you can check directly the method, details, steps, and the answer at the end. The answer. Okay, I think here we can start in the bracket. You see, M union N. I take M and N and find the union. So write it there. Then look at the union and Q, find the intersection between them. I think you have finished now. Let's see. So M union N, see I put here all the details for you. 0246 union 13579. So the union means all the elements in M, all the elements in N, and also in the intersection. So 0, 1, 2, 3, 4, 5, 6, 7, 9. Q, we know Q, Q 0, 2, 4, 6, 8, 10. Find the intersection. 0 is there in the intersection, so it should be in this and in that one. 2 in the intersection, 1 is not in the intersection, 4 in the intersection, 5 is not, 6 is there, yes. 0, 2, 4, 6 is the answer. Let's see, complement. Complement. See, to read this, in the middle of the page here, you can see A complement. We read it as A prime. But listen for the definition. Complement, C-O-M-P-L-E-M-E-N-T. Complement is the set of all elements of U that do not belong to A. We call U is the universal set. U is the universal set. Universal set means it contains all the elements included in the discussion, in the question. So every question we can give you U. So this is like the big set. And we have A. If we need A prime, see the complement, A prime, X such that, read here please carefully, X such that X belongs to U, X does not belong to A. So this is outside the A. This is what makes it complement. So we have U, big set. We have A inside. A prime is in U, not in A, outside the A. Maybe you need an example here. Okay, let's take U, 1, 2, 3, 4, 5, 6, 7. That's U. Let's take A, 1, 3, 5, 7, and take another one, B, 3, 4, 6. See carefully, let's find A prime, B prime. A, 1, 3, 5, 7. What will make A prime? What will complete A to be U? It will be 2, 4, and 6. So that's A prime. A prime in U, remember, in U, not in A. That's A prime. Now B prime. In U, not in B. So 3, 4, 6 is the B. B prime, 1, 2, 5, and 7. There are two little tricky questions here at the end. Phi prime. Phi prime. Phi is the empty. What will make it complete? So phi prime is equal to U itself. U prime. U is the universal set, the big set in the question. U prime, what will make it the complement? Phi. So U prime is phi, phi prime is U. Remember these two little tricky questions. Let's look at question number 11. Given the sets, 4 sets. So I gave you U here. See, this is universal. So this is in the discussion, in this example only. U is 0, 1, 2 until 10. M, set M is 0, 2, 4, 6, 8. And 1, 3, 5, 7 R 0, 1, 2, 3, 4. Let's find, there are two questions here. R union N intersection M prime. It's very important now. You can pause the video, please, and then try these two. Let's try one by one. R union N. So we have where R and N, take the union together, the last two sets here in the second line. Find the intersection. You have to find also M prime. M prime, the elements in U, not in M. But then find the intersection. Did you finish? I think you have finished now. Let's see. Again, I wrote the given here. You can see it in front of your eyes. R union N. So this is R and N. Together will be 0, 1, 2, 3, 4, 5, 7. Yes. M prime. See, M prime is in U, not in M. 1, 3, 5, 7, 9, 10. Find the intersection. Easy to find the intersection. Just look here. The number same. Numbers should be repeated in both sets. So 1, 3, 5, and 7. Now, I'll give you another minute, maybe. You can try this little tricky question. U intersection phi prime all union R, the set R here, 0, 1, 2, 3, 4. What do you think the answer here? Try it, and then we can check the complete solution. This one here, second part. The answer is U. Did you get that one? Let's see carefully. Phi prime, I mentioned before, phi prime is U, because phi is the empty. What will make it complete to make it U? It is U. U intersection U is U. U union R, R is small set, so U intersection R, this is U. So the answer is U, 0, 1 until 10. This is another try at home, nice question. You can try and answer in the next slide. Now, the last part will be the interval notations. When we have sets, we have intervals. Very important to understand the intervals. How do we graph it? How do we draw it? How do we sketch it? We have closed interval. Let's say -2 to 11 means what? All the numbers closed. We have closed. Remember here, there are 3 types of the intervals. So -2 to 11 means closed all the numbers on the number line from -2 closed until 11 closed. Now, if we have open minus infinity until 0. So 0 is not included, minus infinity for sure it is not included. So if it is open, the number is not included. Now we have sometimes half open or half closed intervals, like this one here, look at here. -4 open to 13 closed. So that means -4 is not included in the answer, 13 is included, and all the numbers between. See, this is interval, continuous, all the numbers, the fractions, the positives, the negatives, real numbers, the irrationals, the rationals. So this is a set, it contains all the numbers. I put here 3 examples. X, see here, 3 examples, 1, 2, 3. X less than or equal to -1.5. What does it mean? You should be able to draw it and then write the interval. X is any number less than or equal -1.5. So we start from minus infinity until -1.5 closed. Why closed? Because we have equal here. Equal means this is the end point, it is closed. Now let's look at another example. X greater than -6 less than 7. You should be able to draw it also here. -6 closed to 7 open. So we write -6 closed, 7 open, then we understand -6 is included, 7 is not included, and all the numbers are included. Now look at the last one, little tricky. 3 less than x. 3 less than x, just imagine it. It's easier to rewrite it. Rewrite it, we say x greater than 3. 3 less than x. Same meaning as x greater than 3. So greater than 3, it will start from 3, but open. Open why? No equal here, no equal. So we write open. So it will start from the first number after 3 to infinity. Now let's see here an example. We need to draw the answer of the intersection and the union. Take a minute please to try 1, 3 open. Remember this is open interval, intersection, 2, 7 closed. It's very nice to do it. You have to draw, let me help you here. You have to draw the number line, draw the first set, second one, and then you can see by eyes, you can see the intersection. Second part, you draw the same, 1, 3 open, 2 to 7 closed, then find the union. It's nice to try it, then you can compare your answer to the solution here in the next slide. Take a minute, please, to try number A. Then I will show you the answer. Now, in the first part, the answer is closed 2 to 3 open. Why? See, I put the details in graphing to understand the method. 1, 3, so I take 1 and 3. See, 1, 2, 3. Remember, open. Open, I put open circle. That means 1 is not included, 3 is not included. Okay, leave it up above the number line so that you can see it easily. 2, 7 below the number line. This is only for drawing purposes. 2 to 7 closed at 2, so I put black dot. Close 7 and all the numbers between. Okay, so if you look at the intersection, so we start from 2, all the numbers 2, 2.1, 2.2, 2.3, 2.4, 2.6, 2.7, 2.8, 2.9, 9, 9, 9, 9, 9, 9, until 3. But 3 in the second set, closed. In the first set, it is open 3. So the final answer should be close 2 to 3 open. That means all the numbers. There are many real numbers, you know, many real numbers, 2.1, 2.15, 2.22, 2.36. All the numbers closed at 2, open at 3. Can you try second one, please? Try 1, 3, open, union, 2 to 7, closed. All right, let's see now together. The answer will be open at 1 to 7, closed. See, 1, 3, I write the same set here. 1, 3, all the numbers from 1 to 3, that's an interval. And then I write 2 to 7, closed. I need the union. Union, I take all the elements in set A, set B, and the intersection. So I start from 1. See, but 1 is open. And then I continue. See, 3 is not in the first set, it is in the second. See, 3 here, not in the first, but it is in the second, from 2 to 7. So the answer in the union will be 1 open to 7 closed. You can write any example you like, and then you can try it yourself. Now, this topic is to be continued in lecture number 4. As I mentioned before, lecture 1, lecture 2, lecture 3, lecture 4 are the same topic, real numbers. After that will be different topics. Thank you very much for watching. I hope I can see you in another video with another topic, and thank you very much. So this is lecture 3 in Algebra course. Thank you very much.